60 questions, 120 minutes. No Claude, no documentation, no browser tabs, live proctored. You need 720 out of 1000 to pass. And if you fail, the retake costs another $125. And many candidates prepare for the wrong kind of exam. They study definitions when the test is really measuring architectural judgment. They memorize what MCP stands for. They learn the command flags. They can define an agentic loop. But the exam does not simply ask for definitions. It drops you into a production system that is already breaking and asks which decision fixes it without creating a second failure. The tempting answers often sound technically correct. They are simply correct for the wrong architectural layer. By the end of this video, you will know the 5 diagnostic questions behind the exam, the exact domain weights so you know where to spend your study time, 5 distractor patterns that help eliminate wrong answers, and a 4-week build plan. And all of it comes back to one question: which layer owns the failure? Anthropic launched Claude Certified Architect Foundations as its first technical certification for solution architects building production cloud applications. Initially through its partner ecosystem, access and booking rules can change, so confirm the current official candidate portal before planning your exam. Here is the system we are going to break 5 different ways. An enterprise support assistant receives a refund request for an order placed 6 weeks ago. To complete the case, Claude may need to search the refund policy, inspect the order record, call a payment tool, return structured data, preserve the case across multiple conversations, and escalate when the evidence is ambiguous. Different failure symptoms, different Claude products, but only a few ownership boundaries: the model call, the agent loop, Claude code, and the project workflow, tools and MCP, and context and reliability around the entire system. Keep this architecture visible. We are going to diagnose every section against it. Domain 1: Agentic Architecture and Orchestration. 27% of the exam, the heaviest domain. The first diagnostic question is: who owns the loop? Our refund request reaches Claude. Claude decides it needs the order record. With client-side tools, Claude requests the tool, but your application performs the operation. A tool use stop reason means inspect the request, execute the tool, append the result, and call Claude again. The loop is inspect, execute, append, repeat. This is where people understand the concept and still miss the control flow. Miss execution and nothing happens. Miss the tool result and Claude never receives the evidence. Miss termination control and the workflow may continue after it should stop. Now ask a different question. Should your application own all of that orchestration? Use the lower level API and client SDK when you intentionally need direct control over the loop. Use the Agent SDK when you want more of the harness, including tools, permissions, sessions, and orchestration infrastructure provided for you. The tempting answer often rebuilds a framework from scratch without gaining meaningful control. That is not flexibility. That is responsibility without leverage. Now the assistant must inspect 20 files and several logs before approving the refund. Put all of that exploration into the coordinator's conversation, and the useful decision gets buried beneath intermediate work. A sub-agent performs a focused task in its own context and returns a compact result. Here is what many people miss. Sub-agents are not primarily an intelligence strategy. They are a context isolation strategy. And when one delegated task fails, do not automatically rerun the entire workflow. Check whether successful units already created side effects. If one unit already issued the refund, restarting everything may issue it twice. Domain 1 verdict. Identify who owns the loop. Isolate context-heavy work. Retry only the failed unit when repeating completed work could create damage. Domain 2. Claude code configuration and workflows. 20% of the exam. The second diagnostic question is: where should this instruction live? Our team ships a fix, but one engineer's workflow behaves differently from everyone else's. Claude Code can read personal configuration from the user environment and shared project configuration from the repository. It can also load local project preferences and more specific instructions associated with parts of the code base. If every engineer needs the same convention, it belongs in shared project configuration, not only on one person's machine. Every answer may sound reasonable until you ask, who needs to receive the instruction? One person? The whole team? Only one part of the repository? Scope determines location. But the CLAUDE.md file is not the answer to every repeated behavior. Use the CLAUDE.md file for stable context and conventions. Use a skill for reusable knowledge or a repeatable procedure. Use a hook when code must run at a specific lifecycle event. This is the distinction worth remembering. An instruction asks Claude to comply. A hook makes the system execute. If identity verification must always happen before a refund action, prose alone is weaker than a programmatic control. Domain 2 verdict. Match context to scope, procedures to skills, and deterministic enforcement to hooks. Domain 3. Prompt engineering and structured output. 20% of the exam. The third diagnostic question is, can downstream software trust the response? Our assistant returns a refund decision. Review this carefully sounds precise. But the model has no shared definition of carefully. Replace attitude with observable criteria. Flag a newly introduced dependency. Flag a removed public interface. Flag a refund outside the permitted policy window. Weak prompts describe the desired attitude. Strong prompts define the decision rules. Now separate two things. Scenario questions deliberately collapse structure and meaning. Return JSON is not a production contract. Structured outputs can constrain a response to a defined schema, and strict tool use can validate tool names and inputs. But watch what happens next. Every field has the correct type. The JSON parses successfully, and the refund amount is still wrong. Valid and correct are not the same thing. Validate the structure, then validate the business meaning. Many demos stop when the parser succeeds. Production architecture cannot. If thousands of independent cases can be processed offline, do not build a synchronous real-time workflow simply because it is familiar. Use asynchronous batch processing when immediate latency is unnecessary. Requests are independent and results can be collected later. Sometimes a question looks AI specific, while the correct answer is ordinary workload architecture. Domain 3 verdict. Testable instructions, enforceable structure, validated semantics, and execution mode matched to the workload. If this breakdown is useful, I am turning it into a one-page study tracker with the 5 diagnostic questions, the distractor patterns, and the 4-week build plan. Comment architect and I will send it when it is ready. Domain 4. Tool design and MCP integration. 18% of the exam. The 4th diagnostic question is, can Claude identify, use, and recover from the right capability? Our refund system exposes 3 tools: get order, fetch order details, and lookup purchase. Their descriptions are almost identical. That is not flexibility, that is ambiguity. The tool interface must help Claude distinguish what the tool does, when to select it, what inputs it requires, and what result or failure it can return. The tool description is part of the architecture, not documentation added after the architecture is finished. Lock in this 3-part distinction. Tool design determines selection. Error design determines recovery. Transport design determines connectivity. Something went wrong gives the agent no reliable recovery branch. A useful failure tells the system what category occurred, whether another attempt is safe, and what information is available for recovery. The difference between a demo and a production agent often appears after the first tool failure. MCP standardizes how Claude products can connect with external tools and data. But do not memorize a universal shortcut such as local always means standard input and output, and remote always means server sent events. Connection options depend on the Claude surface and deployment model. For example, the Messages API MCP connector connects directly to remote MCP servers by URL. Local standard input and output servers require a separately managed MCP client rather than connecting through that API feature directly. Domain 4 verdict. Design tools for unambiguous selection, return actionable failures, and choose transport from the actual deployment boundary, not habit. Domain 5. Context management and reliability. 15% of the exam. The 5th diagnostic question is, what must survive outside the current model turn? Our refund case now spans 3 days and 4 conversations. The approved amount cannot live only inside the model's active context. Durable case state belongs in structured application storage. 3 systems are constantly confused. Context is what Claude can see now. Memory is what the application preserves. Cache is what the system avoids recomputing. A larger context window is not a database. Compaction and context editing can keep active context useful. They do not replace the system of record. Prompt caching reuses stable prompt prefixes to reduce repeated processing cost and latency. It does not guarantee that a business fact survives correctly across a workflow. Reliability also requires bounded retries, idempotent operations, checkpoints, observability, and human escalation when the system lacks enough evidence or authority. Domain 5 verdict. Externalize durable state. Manage active context deliberately. Cache stable prefixes. And escalate uncertainty instead of manufacturing confidence. Now let us solve one scenario the way an architect should. A refund tool must never execute until customer identity has been verified. Which control best satisfies that requirement? A. Add a programmatic prerequisite that blocks the refund until verification succeeds. B. Ask Claude to produce a confidence score before every refund. C. Add an instruction telling Claude to verify identity first. D. Increase the context window so the verification remains visible. Take 5 seconds. B is a confidence estimate. Confidence is not authorization, wrong layer. C is the tempting answer, but it is still an instruction. Must never requires enforcement, not encouragement. D is the context trap. Making information visible does not create a control. A is the answer because it makes the unsafe action structurally unavailable until the prerequisite succeeds. Notice what happened. You did not need to recall a product name. You identified the layer that owns the guarantee. Compress the entire guide into 5 patterns. Trap 1. A vague prompt is offered as the fix for an operational problem. Choose measurable criteria. Trap 2. A summary is offered where durable structured state is required. Choose the system of record. Trap 3. The whole workflow is retried after one component fails. Check completed side effects first. Trap 4. Shared behavior is stored in personal configuration, or mandatory enforcement is left as an instruction. Match the mechanism to the scope. Trap 5. A tool or transport is selected because it is familiar. Start from the deployment boundary and failure mode. The convincing distractor often fixes the visible symptom at the wrong architectural layer. 4 weeks. Build, do not only read. Week 1. Build the client-side tool loop. Log every stop reason. Add termination limits. Then rebuild the same workflow using the Agent SDK and document what the framework now owns. Week 2. Create a repository with personal, shared, local, and directory scoped guidance. Turn one repeatable procedure into a skill. Turn one mandatory control into a hook or programmatic prerequisite. Week 3. Build structured extraction with schema constrained output. Add semantic validation. Then create a batch version for offline work. Week 4. Build an MCP server with clearly differentiated tools, actionable failures, and a recovery path. Then add durable state, caching, bounded retries, and human escalation. After every week, practice timed scenario questions. But do not only ask which answer is correct. Ask which layer failed, why are the other answers tempting, and what new risk would each wrong answer create. That final question turns memorization into architectural judgment. Do not memorize Claude products as isolated features. Find the broken layer. Choose the smallest reliable fix. Then prove the system still behaves correctly when the tool fails. The context grows or the model is uncertain. The certification is not only testing whether you know Claude, it is testing whether you can assign responsibility inside a production system. That is the difference between knowing Claude and architecting with it. In the next video, we will build the week 1 project, the client-side tool loop first, then the higher level agent version side by side.